Now let's work on part C of problem cp031-133. And again, we want to determine v sub x and I sub x. So v sub x and I sub x are on the right hand side of the circuit, but there's no way I can find any values from the information that I was given. So I have to somehow look and see if I can work my way around until I can actually get those values. So I can see that if I write a Kirchhoff's voltage law equation around this loop, and I'm going to call this KBL1, I can then write the following equation: minus 60 volts plus 5 times 8 is 40 plus, and I'm going to just assume that this is going to be v sub a equals 0. So I can solve for v sub a, and v sub a is going to be equal to 60 minus 40, right? Because I keep v sub a on this side, I send this to the other side negative, and this one becomes positive. So this becomes 20 volts positive. Now, with this information, now I can find the current that flows down this path. And it flows down this path because I'm going to apply passive sign convention, and I know that passive sign convention says that if the current enters the positive terminal, I will have a positive voltage, and that's what I have, 20 volts. So the current it will be flowing down, and that means in this case I'm just going to call this current I sub a, that is the voltage v sub a across the 10 ohm resistor, and that's 20 divided by 10. That's going to be 2 amps. Well, if this is node number 1, then I can write a Kirchhoff's current law at node 1, and I see that I have 5 amps going into this node, and I have this 2 amps, and this current that I'm just going to call it I sub b, that also goes out. And so now I can solve for I sub b. I sub b then becomes 5 minus 2, that will be 3 amps. Since this current flows through this 4 ohm resistor, now I can find a voltage across the resistor, and I'm just going to call this voltage v sub b. That is going to be the 3 amps times the 4 ohms, and that is just 12 volts across this resistance. Now, since I have voltage across the 10 ohm resistor, voltage across the 4 ohm resistor, I can write another Kirchhoff's voltage law loop, and this is going to give us the following. I have v sub a, that is minus 20 volts when I go around the loop, and then I have this plus 12 volts, and I'm just going to call this v sub c, this voltage across the 2 ohm resistor v sub c, and this is equal to 0. So v sub c is solving for the equation, sending this to the other side as positive and this one as negative, is going to be equal to 8 volts. So being v sub c 8 volts, and we know that this is in parallel with this element, then we can conclude that v sub x is equal to v sub c, and that's equal to 8 volts. Now, what is the value of I sub x? Well, we have to look at this node, and I'm going to call this node number 2. And I can write a Kirchhoff's current law at node 2, and I will have this I sub b current going into this node, and I will have this other current going out. So we call that current, I think over here, well, we haven't found that current, so that will be, let's call it current I sub c, and then we see that this current is coming in, so it's going to be minus I sub x. But what is current I sub c? Well, I sub c is this voltage v sub c divided by 2 ohms, and voltage v sub c, if you remember, was equal to 8 volts, so 8 divided by 2 is 4 amps. That means that if I sub b was equal to let's move this over here. I sub B was equal to 3 amps, and I sub C is equal to 4 amps. Then I sub X, when we solve for this equation, I sub X equal to I sub B minus I sub C. Then I sub X is just I sub B is 3, I sub C is 4, I sub X is equal to minus 1 amps. And that's the solution.